we are beginning with the chapter, that is we are continuing in the chapter complex numbers and quadratic equations. So dear students, in our previous two sessions we have discussed about complex numbers, addition of two complex numbers, multiplication of two complex numbers, and after that we have studied about the powers of I and the conjugate and modulus of this complex numbers. So today in this session we are going to discuss about how we are going to represent these complex numbers in the Argand plane or in the polar representation. Today we are just going to study about the representation of complex numbers, that is Argand plane and polar representation. Argand plane and polar representation. As for those numbers, see, we used to represent numbers on the x and y axis, right? The same way here we are also going to represent these complex numbers along x and y axis. This is positive x axis represented as capital X, and this is negative x axis represented as x dash, and next this is positive y axis represented by capital Y, and this is negative y axis represented as y dash. So what these arrow marks indicate? These arrow marks indicate that the line still goes on. So now we are studying about the representation of complex numbers. Here along the x-axis, complex number is of the form a plus I into 0, which is on the x-axis. Here only we are going to write the a, that is x term, that is here on the x-axis the y terms will be equal to 0. The same way along the y-axis or on the y-axis, complex number is of the form 0 plus I into b, that is on y axis the x term will be equal to 0. Here the complex number which we are considering x plus iy. What is the complex number here? The complex number z is x plus I into y, that we are representing. Then next complex number x plus iy, which corresponds to the ordered pair. This can be represented geometrically. How we are going to represent it geometrically? With the point P of xy on this plane, that is on this plane. For example, if you want to represent, if both x and y axis are positive, we are going to represent it in the first quadrant. Then what about the second quadrant? If x is negative and y is positive, it is going to be represented in the second quadrant. If both x and y axis are negative, then they are going to be represented in this third quadrant. And if x is positive and y is negative, that is represented in the fourth quadrant, represented by the point what? Can write as P of x comma y. It is represented by the point P of x comma y. Then in this xy plane, see, in the Argand plane, the modulus of this complex number. So how we are going to write the modulus? Modulus is nothing but the distance of the point from the origin, right? The modulus of this complex number, if the modulus of the complex number x plus iy, it is given by root of x square plus y square. What it is? It is the distance of the point P from the origin. That is the distance of the point from the origin. Modulus is given by x plus iy is equals to root of x square plus I square. The points on the x-axis, as I said, corresponds to a plus I into 0. See, here I have said already, on x-axis it is a plus I into 0 and on the y-axis 0 plus I into b. Here what is going to happen? The same is, x-axis is called the real part and y-axis is called as imaginary part. Okay, how we are going to write? The x-axis, that is called as what? The x-axis is called real axis. The x-axis is called real axis and y-axis is called as what? Is called imaginary axis. See, x-axis is called as real axis and this y-axis is called as imaginary axis. The representation of complex number. See, if z is x plus iy, we are going to write it in the form of p of xi, the representation, and then the conjugate of z, what it is? It is x minus iy. We have already studied the conjugate of complex numbers. If z is x plus iy, its conjugate is going to be what? X minus iy. See, then I want to represent the points, then how I am going to represent? P of x comma y and q of x comma minus y. Here what is going to happen actually is, this P of xy and or OP is and OQ is exactly the mirror image of what? It is going to be the mirror image of OP. OQ here, it has become the mirror image of OP. Then next, this is how we have represented this complex numbers. What about the polar form? Now let us study polar representation of a complex number. Okay. Polar we have represented this in the argand plane. Now we are going to study about polar representation of complex numbers. Next is polar representation of complex numbers. Just draw it. Same, x, y, x dash and y dash, p, r, it is modulus of z. Let this be the angle theta. P of z, origin. Then what we are going to write? Let P be the any point. Okay. Then let the point P represent the complex number. Let P represent the what? Represent the complex, non-zero complex number. Okay. If it is going to represent the non-zero complex number, that is z is equals to x plus iy. Non-zero complex number, z is equals to x plus iy. Let the directed line segment OP B. See, this OP, this directed line segment OP, it is of the length R. Okay. If it is of the length R, let the directed line segment OP be of what length? Be of length R. Okay, if it is the length of R and theta, what it is theta? It makes the angle along positive x-axis, right? What it is? Theta is the angle which is making along the positive direction. We are going to write it as theta be the angle which OP makes with, and theta be the angle which OP makes along which axis? Along positive x-axis. It is making the angle along positive x-axis. If so, what we can say? The ordered pair R comma theta. Here the ordered pair R comma theta is called as what? Is called the polar representation of this complex number. Is called the polar representation of what? Representation of complex numbers. Polar representation of this, or we can just say that they are the polar coordinates. Better we say polar coordinates of the point P. Polar coordinates of point P. They are the polar coordinates of the point P. Then how we are actually going to write it? Then we are saying that x will be equal to r cos theta and y will be equal to r sin theta. How we are going to write it? We are going to write it as z is equals to, first we have x as r cos theta and we have y as r sin theta. Then how we are going to write z? And therefore z will be equal to what? Z will be equal to r cos theta plus I into sin theta. What it is? Z is equals to r into cos theta plus I into sin theta. So this is actually called as the polar representation of complex number. What it is? This z is equals to r into cos theta plus I into sin theta is there, no? This is the polar representation of this complex number. This is said to be the, this is said to be what? Polar representation of complex numbers. And then what about the modulus r? How we are going to find? R is equals to mod of z. This is how we are going to find the modulus of the number, right? R is equals to mod of z. How we are going to find it? I had just said by explaining the argand plane, that is root of x square plus y square, that is going to be of the form root mod z. How we are going to find? Root of x square plus y square is the modulus of z, and theta is called the argument of z. What it is? Is the modulus. It is the modulus of z, and theta we have, right? and theta is called the argument of z, or we call it as amplitude of z, and represented by what? And represented by argument of z. This is all about the polar representation. What it is? If P is the any point and OP is any directed line segment and theta is the angle made by the line OP along this positive x-axis, then the r comma theta, they are the coordinates of this point P. And what is, how we are going to consider? X as r cos theta and y as r sin theta. Then z is equals to r into cos theta plus I into sin theta. This is the polar form of the complex numbers, where what we are going to find? R, it is the modulus of z, that is root of x square plus y square, and theta, it is called as the argument of z, or it is called as the amplitude of z. Now let us focus on few of us. Let us solve examples and then later move on with the exercise. How we are going to represent in the polar form, that is all we are going to see in the example and in the exercise part. First, let us solve one example. Or let us look over the exercise part. Exercise 5.2. What is given? Find the modulus and the argument of the complex numbers. What we are supposed to find? Find the modulus and arguments of what? Of each of the complex numbers. Of each of the complex numbers. Among that, what is the first question given? The first one is given that z is equals to minus 1 minus I into root 3. See how we are going to represent x. X is r cos theta, right? And y will be equal to r sin theta, right? We have this. Then what it is? Let r cos theta, what it is given? It is minus 1. And r sin theta, what they have given as r sin theta? It is minus root 3. Let us add and square it on adding and squaring. What we are going to get? We are going to get it as r cos theta square plus r sin theta square. This will be equal to what it is? It is minus 1 square plus minus root 3 square. I am here going to get as r square cos square theta plus r square sin square theta. Minus 1 square is obviously 1, plus minus into minus is going to be plus root 3 square, that is root on cancelling root and square, I am left with 3. See, here I have r square as common, take it out, that is r square into cos square theta plus sin square theta. This will be equal to what? 4. Then r square will be equal to 4. Why r square is equals to 4? We know that because cos square theta plus sin square theta, what is it? Its value is equals to 1. That is why what we have taken, r square into 1 is nothing but r square. r square is equals to 4. Then what is going to happen next? R will be equal to root of 4, which is nothing but r is equals to 2. Why we haven't taken plus or minus? Because always, that is conventionally, r is greater than 0. That is why what we have taken? We have taken r is equals to 2. So now we got the value of r. What we are going to do the next? Now what we do is, we got the modulus, that is its value is 2. Then how we are going to write? R cos theta. R cos theta is minus 1. In place of r, we are going to substitute 2. That is 2 cos theta is equals to minus 1. Therefore, cos theta will be equal to minus 1 by 2. And what we have? And we have r sin theta is equals to minus root 3. Right? Therefore, what is going to happen? 2 times of sin theta is equals to minus root 3. Sin theta is equals to minus root 3 by 2. See students, just notice we have both the values negative. Where do we find both the negative value? We are going to find that in the third quadrant, right? Since both the values are negative in the third quadrant, how we are going to find the argument? Argument will be equal to minus of pi minus pi by 3, because they lie in the third quadrant. We are going to get it here as minus 2 pi by 3. How I got 2 pi by 3? On taking the LCM. That is minus 3 is our LCM. 3 pi minus pi, which is equals to minus 2 pi by 3. Hence we found both modulus, which is 2, and argument as minus 2 pi by 3. That is this is the complex number we have, that is equals to minus 1 minus I root 3. Its our modulus is 2 and its argument is minus 2 pi by 3. I hope students you all have followed. What we have done? We have just compared. R cos theta will be equal to minus 1 and r sin theta will be equal to minus root 3. Squaring and adding, we got r into cos theta square plus r into sin theta whole square. We got it as r square is equals to 4. We got r as 2, which is the modulus. To find the argument, we got that since both these numbers are negative, it is going to lie in the third quadrant. That is why it is minus of pi minus pi by 3. On simplifying, we got it as minus 2 pi by 3. So, for this, the modulus is 2 and argument is minus 2 pi by 3. I hope you all have followed this. Now, the second problem is just exactly the same to it. We are going to solve the next main. What is the next main given? It is given that convert each of the complex number in the polar form. What we are supposed to do? Convert each of the complex number in which form? In polar form. What is the polar form we have? We had the polar form as z is equals to r into cos theta plus I sin theta, right? That is what we are supposed to convert here now. Among that, the first one is 1 minus I. The same way as we have done the previous problem. Find the solution, that is let r cos theta is equals to 1 and r sin theta. What will be the value of r sin theta? It is going to be minus 1. What is our next step? On squaring and adding. On squaring and adding, we get what? We get r square cos square theta plus r square sin square theta, that will be equal to what? 1 square plus minus 1 square. We have r square common, that is cos square theta plus sin square theta is equals to 1 plus 1. Then what is going to happen? R square is equals to 2. Why r square is equals to 2? Just now I have said that cos square theta plus sin square theta, its value is equals to 1, and that is why r square into 1 we are going to get it as r square itself. Therefore r square is equals to 2 and r will be equal to root of 2. Now in place of r we are going to write it as root 2. That is, I have r cos theta. What is the value of r cos theta? It is 1. I got r as what? Root 2. That is root 2 cos theta is equals to 1. Cos theta is equals to 1 by root 2. And similarly what I have? R sin theta, it is equals to minus 1. Nothing but root 2 sin theta is equals to minus 1. Therefore what I have? I have sin theta is equals to minus 1 by root 2. See, I have one as positive and the other as negative. That is, I get, when we have the value as 1 by root 2, when theta is equals to pi by 4, right, we are going to write therefore theta is equals to pi by 4. But see, we have theta which lies in the fourth quadrant. Why it lies in the fourth quadrant? Because x is positive and y is negative. We write theta lies in fourth quadrant, right? Then we are supposed to represent it in the polar form. How we are going to write it? We have z is equals to what? R cos theta plus I sin theta. What is z given? They have given z as 1 minus I. I have r as what? Root 2 cos of what? Pi by 4, right? Because theta I got the value as pi by 4 plus I into sine of what? Minus pi by 4. This is what? This is the polar representation. It is the required polar representation. We are going to write this is the required polar representation. I hope students you all are following. We have just represented, we know z will be equal to r cos theta plus I into sin theta. R cos theta is 1 and r sin theta is minus 1. On squaring and adding, we got r as root 2. So in place of r, we have substituted root 2. When we know that the theta will be equal to 1 by root 2, when its value is equals to pi by 4. And also theta lies in the fourth quadrant. Why theta lies in the fourth quadrant? Because x-axis is positive and y-axis is negative. Then obviously it is going to lie in the fourth quadrant. Then its polar form is root 2 into cos pi by 4 plus I into sine of minus pi by 4. Let us solve the next problem. What is the next problem given? It is given that minus 1 plus I. Our solution will be what? Same, just go on repeating the steps. Let r cos theta will be equal to, here it is minus 1, and r sin theta will be equal to what? It is going to be plus 1. then squaring and adding, we get r square cos square theta plus r square sin square theta. This will be equal to minus 1 square plus 1 square, nothing but r square cos square theta plus sin square theta, just taking out r square common, that will be equal to 1 plus 1, because minus 1 square is again plus 1 itself. Therefore r square is equals to 2. As I have said, cos square theta plus sin square theta will be equal to 1. Therefore r is equals to root 2. Now again the same thing. Now what we have? We have r cos theta, its value is minus 1. R we got it as root 2. Root 2 cos theta is equals to minus 1. Cos theta is equals to minus 1 by root 2. And what we have? R sin theta, its value is 1. Root 2 sin theta will be equal to 1. Sin theta will be equal to what? It will be equal to 1 divided by root 2. Again, one way will be having the value of theta as 1 by root 2 when it is equals to pi by 4. Theta is equals to what? Theta is equals to pi minus pi by 4, which I am going to get it as 3 pi by 4. See here, what actually happens is, we write it as, then we got theta as 3 pi by 4. Since we got theta as 3 pi by 4, how we can write it in the polar form? So we can write as what? What it is given? Minus 1 plus I will be equal to r cos theta, that is root 2 cos of 3 pi by 4 plus I into root 2 sin of what? Sin of 3 pi by 4. Yes or no? R cos theta plus I into r sin theta. Then it is going to be of what form? Take out root 2 common. Root 2 into cos 3 pi by 4 plus I into sin 3 pi by 4. This is what? This is the required polar form. This is the required polar form. All the problems are similar to it. First we are going to find out r, write down r cos theta, then r sin theta. Then first let us square it and add. We are going to get it in the form of r square into sin square theta plus cos square theta, where sin square theta plus cos square theta, its value is 1. So here we are going to find the value of r. On finding the value of r, we are going to substitute it in place of r cos theta and r sin theta. By that, what we come to know? We come to know that theta lies in the which quadrant. Once we get to know that theta lies in which quadrant, we can easily write it in the form of polar form. Let us solve a few more problems of the same exercise still. Almost all the problems are same. We need to just follow the same methods, only they have given some different numbers, that's it. What it is, the next one? Minus 1 and it is minus I. Minus 1 minus I. How we are going to find the solution? Again same. Let r cos theta is equals to minus 1 and r sin theta is equals to minus 1. Then squaring and adding. Squaring and adding, we get what? First square it, that is r cos theta square plus r sin theta square, that is we are going to get minus 1 square plus minus 1 square. Then what we are going to get? R square cos square theta plus r square sin square theta is equals to 1 plus 1. We have r square common, take it out. R square into cos square theta plus sin square theta is equals to 2. We all know that cos square theta plus sin square theta, its value is equals to 1. That is why r square is equals to 2 and r is equals to root of 2. Next what we are going to do? Now what we have considered? We have considered r cos theta is equals to minus 1. In place of r, substitute root 2 cos theta is equals to minus 1. Cos theta is equals to minus 1 by root 2. And the same way we have r sin theta. R sin theta is what? Which is also minus 1. That is root 2 sin theta is equals to minus 1. Sin theta is equals to minus 1 by root 2. See, notice we got both x and y as a negative. Then it is going to, that is theta is going to lie in the third quadrant. So what we are going to do? Therefore, theta is equals to, because it lies in the third quadrant, minus of pi minus, it is 1 by root 2 means it is pi by 4. Pi by 4, which is nothing but minus of what? 4 pi minus pi by 4. You are going to get it as minus 3 pi by 4. You got theta as what? Theta as minus 3 pi by 4. So how you are going to write it now? We are going to write it as, therefore minus 1 minus I is equals to, we have r as what? R as root 2. R cos theta, cos of minus 3 by 4 plus I into sine of minus 3 pi by 4. It is what? This is the required, polar form. So let us solve one more problem. What it is? We need to find in the polar form of what? Minus 3. They have given us minus 3. Then how we are going to solve it? Again consider the same steps. That is, let r cos theta is minus 3. But see, we do not have any number of the y-axis, that is imaginary axis. We do not have any number of I. Then how we are going to write? We write r sin theta is equals to 0. On squaring and adding, on squaring and adding, we get r square cos square theta plus r square sin square theta as what? Minus 3 square plus 0. That is r square cos square theta plus sin square theta is equals to what? Sorry. Minus 3 square. That is, I am going to get it as plus 9. Cos square theta plus sin square theta, as it is 1. R square is equals to 9. R will be equal to root of 9. Therefore, R will be equal to 3. Why R is always taken as 3? Conventionally, we have considered that always R is greater than 0. Why? Because it is modulus, right? Modulus can never be negative. That is why R is equals to 3. Then how we are going to get it? We get it as R cos theta is equals to minus 3. That is 3 cos theta is equals to minus 3. Cos theta is equals to minus 3 by 3. Nothing but cos theta is equals to minus 1. 3 and 3 get cancelled. We are going to left with minus 1. And what we have? We have r sin theta is equals to 0. That is 3 sin theta is equals to 0. Sin theta is equals to 0 by 3. Nothing but sin theta is equals to 0. For what value of theta we have it? Cos theta as minus 1 and sin theta as 0. We know that it is going to happen when theta is equals to pi. Therefore, theta is equals to pi. Hence, we have minus 3 is equals to r cos theta plus I sin theta. How we are going to get? R is 3 cos of pi plus I sin pi. This is required what? This is our required polar form. Our required polar form. We know that when theta is minus 1 and when theta is 0, it is when the value of theta is equals to pi. Now let us solve one more problem. What is the problem given? It is, just solve last one more problem, that is I. See, in the previous problem we had x component as 0 and here we have y component. There we had y component 0, here we have x component 0. Then what is going to happen? Let r cos theta is equals to 0 and r sin theta, its value is 1. So, squaring and adding, what we are going to get? We are going to get it as r square cos square theta plus r square sin square theta. That is 0 plus 1 square. R square cos square theta plus sin square theta. It is 1. R square is equals to 1. R is root of 1 is nothing but 1. Therefore, we have r cos theta is equals to 0. Nothing but 1 cos theta is equals to 0. So, cos theta is equals to 0. And we have r sin theta is equals to 1. Value of r is 1. 1 sin theta is equals to 1. Therefore, sin theta is equals to 1. Again the same thing, when we are going to get cos theta as 0 and sin theta as 1, when the value of theta is equals to pi by 2. Therefore, theta is equals to pi by 2. Hence, how we are going to represent that in the polar form? We have I, which is r of cos theta plus I sin theta. Value of r is what? It is 1. 1 into cos of pi by 2 plus I sin pi by 2. 1 into is nothing but we are going to get the same value, right? Therefore, it is cos pi by 2 in plus I into sin pi by 2. This is our required polar form. So students, we studied how to find the modulus and argument of the complex number and polar form of the complex number. To find that, what we are supposed to do first find what is r cos theta and r sin theta. Squaring and adding, you will get the value of r. On substituting it in r cos theta and r sin theta, we are going to get the value of theta depending upon the quadrant. Then we are going to find its polar form. What is the polar form? It is z is equals to r into cos theta plus I into sin theta. So, I hope you all have followed each and every part studied in this session, that is representation in the argand plane and in the polar form. how we are going to find the polar form of these complex numbers, modulus of complex number and argument of z. Apart from that, all these problems we have solved in this session. So students, keep studying, stay safe. Thank you.